100% comfortable with SOHCAHTOA now, yes? And when I say 100% comfortable, I mean just that. 100% comfortable with SOHCAHTOA. If I ask you to do some SOHCAHTOA work, you should be at the point where you don't even need to write theta opposite adjacent. You can just see it in your head. Theta opposite over adjacent. So I've got the adjacent, so it's 52, 10, 57. I understand you can have that happen, but everybody is pretty comfortable, yeah? All right, so just a reminder, let us please notice how much space I have given here. We're going to be using up that space. So what is sine? Opposite over the hypotenuse. Excellent. So write in all three. I know you already know it, but I want you to write it in anyway. There's a reason. I'm going somewhere with this. Where was I? Right there.
It's kind of crazy to think how people in Greece formulated it. Who formulated it? Obviously the Greeks, because they do everything math now.
No, lots of people did lots of math. Just because we are Eurocentric, we only talk about the Greeks. But at the same time, the Greeks were figuring all this stuff out. The Egyptians were figuring all this stuff out. Indian mathematicians were figuring all this stuff out. Arabic mathematicians were figuring all this stuff out. All right, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. We already knew all that, yes? Now, you also know what this represents. This represents what we call, it's got two names. It's got the name that all your teachers were taught, but that name is named after a white European mathematician, so we don't use that name anymore. But I am going to use it once in a while because that's what I was taught. This is called, for you guys, the coordinate grid. Right? The way I was taught was after the man who invented it, who was the French philosopher René Descartes. And we called it the Cartesian plane. All right? And you already know how to use it. What is the horizontal line? X. What is the vertical line? What is the proper name for this line? It is the x-axis. What is the proper name for this? It is the y-axis. And on this grid, every single point on the grid is written as x, comma, y. Right? Over here are the positives. Over here are the negatives. Down here are the negatives. Up here are the positives. You all know how to read this thing. You should be able to read it in your sleep. Yeah? Excellent. What do you call that point right there? Pardon? I thought I heard somebody say it. No. Pardon? No. Its coordinates are 0, 0, absolutely. Origin, excellent. That point is the origin. That's where we start from. Yeah? Okay, now, you can quite plainly see that the Cartesian plane is divided into 4 pieces. Those 4 pieces are called quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Everybody cool? In quadrant 1, what is every single coordinate? Positive. X, Y. In quadrant 2, what are the coordinates?
negative, positive, goes X, Y.
Negative goes first. Negative x, positive y. What about here?
Negative, negative.
Negative x, negative y, and here? X, negative y. Is everybody good with the coordinate plane? Yeah? Okay. Now, somebody give me a set of coordinates. Okay. Put that on the graph. 2, negative 4. So our coordinates with which we are working, 2, negative 4. So where would that be? Quadrant 4. I would go out 2 and down negative 4. I'm going to have to erase now. That's a crap 2. Everybody agree? Okay. Now, make that an angle. And draw the other one right there. There, we now have an angle. Everybody cool? Everyone agree? I've made an angle. I've gone down to here. And, all right. This is what we call, and I'm going to use the yellow, an angle in standard position. Okay? An angle is in standard position if, and there's 2 things that you have to know. 1, the vertex is at the origin. Is that the case here?
Yeah.
Where's the vertex? What is the vertex of an angle? How do you find the vertex? What? Yeah, it's where the lines meet. It's the corner, right? And this corner is right at 0, 0. Everybody agree? So we've met that criteria. The second criteria is as follows. Now, I'm using the word line, but there's another word for it. I'm going to use that in a minute. One line is the positive x-axis. Do I have that here? Everyone agree? Okay. Now, please put quotes around line, because it's not technically geometrically a line. Geometrically, a line goes to infinity in 2 directions, whereas this line I have drawn here does not go past 0, does it? So what this really is a ray, because it starts from one point and goes to infinity in one direction. Everybody cool? Okay. One ray is the positive x-axis, and that ray is called the initial arm. Please highlight that word because I'm going to be using it all the time. And I'm going to use blue to show it up here. The initial arm. What does the word initial mean in English? It's got a lot of meanings. What are some of them? First is the one I wanted. Usually people say, well, my initials are LM. But no, I'm glad you went first. So, initial arm, this is the arm that, and I'm going to use green, this is the arm that starts the angle. Because it's the initial, it's the first arm, okay? The other ray forming the angle, which I'm going to highlight with green, the other ray is what we call the terminal arm. because that's where the angle ends. Is everybody cool to there? Yeah? Okay. Now, if I start right here on the x-axis, my initial arm, because I'm in standard position, there are two directions I can go to get to here, isn't there? Right? I could go clockwise. Right? I mean, counterclockwise. I could go up, which is counterclockwise. Unless you're in Europe, and then it's anti-clockwise, as opposed to uncle-clockwise. Nothing? Anti-clockwise? Uncle-clockwise? Nothing? I could go counterclockwise, or how else can I get there? I could go clockwise. Everybody with me? Now, because there's two directions I can go, there's two things we have to think about. In all of math, how many directions are there?
4.
That's real life. 2. What are the two directions in math?
Up and down.
No. Positive and negative. So one of those must be positive, one of those must be negative, yes? You guys are smart young people. If I start here and I go counterclockwise, I'm going up, yes? What sign do we associate with up? Positive. So, counterclockwise rotation is positive degrees. Now, that's weird, isn't it? Okay, don't write down what I'm about to write down. Call your minds back to directions. Oops. North, east, south, west. What's north?
No, negative.
North is 0. What's east? 90. So we went clockwise and started up here, and it was positive when we do directions. Everybody understand? Completely the opposite when we are doing...
Because the angle of the initial arm is 0 this time.
The initial arm is where we start. Everybody cool? So counterclockwise rotation is positive degrees, which means let's not make this any more difficult than it needs to be. The opposite of counterclockwise is clockwise. So the opposite of positive is negative degrees. Is everybody cool? Yeah, we're going to draw it again, as a matter of fact. Down here, everybody please draw and look at the cool thing I can do. Yeah, buddy. Everybody draw yourselves a coordinate grid. Yeah? Everybody draw for me an initial arm. So everybody draw where it would go on our new coordinate grid. I believe the initial arms I highlighted in blue. So where is my initial arm got to go?
It has to be the one over there because it has to be on the positive x-axis.
Everyone agree? All right, now we are going to draw 3 terminal arms. All right, we are going to draw 1 terminal arm in quadrant 1. Draw it. Everyone's going to be different because nobody's going to make it the same. Everybody cool? Okay. How would we measure that angle?
Counterclockwise.
I start here and I go up. So this is my theta. What is the largest it can be and still be in quadrant 1? 89.99999. 90. Everybody cool? Yeah? Okay. Now, I'm going to use a different color. Now make your terminal arm into quadrant 2. Where's theta? Where do I start counting from? The initial arm. And where do I go? I go to the terminal arm. Yes? Okay. How far is this part?
It's huge.
90. So what's this?
Like 120.
90 plus that. Or what else is it? 180 minus. Is everybody cool? I'm going to stop for a second, make sure everybody's on board there. Yeah? All right. Now I'm going to make a green line into quadrant 3. Where's theta start? Still starts at the initial one. Now it goes where? All the way around, which means, what is it to here? What is it to this line? 180. So this is 180 plus. Or 270 minus. Everybody cool? And finally, I'll make a blue line down there. What's theta? In here it is what? What is it in here? 270 plus or 360 minus. But please notice the thetas are all between the initial arm and all the way around. Is everybody with me? Yes, always. Is everybody with me? We always start on the positive x-axis, and theta is between the positive x-axis and the terminal arm always. Everybody cool? All right. Do A, B, C, D, E, F right now on page 73. Remember, you do not need to get out a protractor. Sketch them. If you are having trouble with what I mean by sketching, here is what I mean by sketching. 30 is about a third of this, yes? So you need to have a line going up about a third of the way. Okay? Have the right quadrant. That is more than enough to make me happy. Do those 6, go. And then put in the symbol for theta where theta lives. Will 1 more minute be enough time? Excellent. All right, are we all good? Okay. So where's theta here? Right in there. Yeah? Okay. Where is the terminal arm going to be in letter B? In quadrant 2. It's going to be out here. Where's theta? Right there. Where is it going to be in letter C? All the way around and down here in quadrant 3. And theta is there. D? Quadrant 1. Theta is there. E? Quadrant 4. And theta is there. And F? Quadrant 2. And theta is there. Did everybody get all those right? If you didn't, do you see why? Everybody's cool? All right. These are all have theta in standard position. Everyone's good, yes? 100%. Okay. Given an angle in standard position, which we know what that means, you've just drawn 6 of them, yes? What do you notice about how we would calculate this? That's 180 minus, yeah? How would you calculate this? You could do 270 minus or 180 plus, yeah? What about this one? 260 plus, 270 plus or 360 minus, yes? What about this one? Back that way. Everybody with me? Everybody sees that, yeah? Every time you put an angle in standard position, you get a theta, right? But that theta has another side, doesn't it? The other side is what we call the reference angle. And it's a reference because we can use it to find our initial. The reference angle is the angle formed by the terminal arm and the closest x-axis. Please do something to remind yourselves that it is the closest x-axis. We can use the y-axis to find angles, right? You've all seen that. But the reference angle is especially locked into the x-axis. Is everybody cool? Okay, so here's what we're going to do with that. Is your R all of yours blank here? Yeah. Excellent, good. So we have 4 of them, so obviously we are going to do an angle in every quadrant, yes? So somebody give me a value that would be in quadrant 1. 75, great. 75, agreed? What's theta? Okay, what's the reference angle, which I'm going to write in green? The angle formed by the terminal arm and the closest x-axis. Here's the terminal arm. What's the closest x-axis? It's right here, isn't it? Isn't that the closest x-axis? So what does that tell you in quadrant 1? Theta, what's the reference angle? Right. In quadrant 1, theta equals reference. Everybody with me? Okay. Give me an angle that would be in quadrant 2. Give me a value. 115. So we're out here. Theta is where? It's 115. The reference angle, which is green, is where? Where's the closest x-axis to the terminal arm? Right there. So what is it?
75. 65.
180 minus theta in quadrant 2, right? So this is quadrant 1. In quadrant 2, it's 180 minus theta. Yeah? Okay. What is a value that will be in quadrant 3? That's a pain to draw.
220.
Great, 220. Where's theta? 220. Where's the reference angle? This is the weird one. What's the closest x-axis? It's backwards. So it's not 180 minus theta, it's
270 plus 360. 270 minus 40. 360 minus.
can't be 180 plus theta, because theta is 220.
It's 270 minus.
So it's
360 minus.
theta
Oh, wait. 180.
minus what?
Wait a minute.
Theta minus 180 in quadrant 3, right? Because that's 180 of it. You know that's 40. How do you find it? 220 minus the 180.
So it just goes towards the nearest one.
Everybody goes to the nearest x-axis. That's why I put the blue cloud around it. And finally, give me a value in the
330.
330. Where's theta? All the way around is 330. The reference angle is where? Closest x-axis right there. How do you find it?
Minus.
360 minus theta. Is everybody good?
Kinda. We'll get there.
Well, you're about to prove it. Do what we just did 4 times. Go. All right. Where is it?
First quadrant.
First quadrant, and it's low.
Pretty low.
So what's theta? 15. What's reference? 15. References are in green. 120 out here. What's theta?
120.
120. What's reference? 60. 250 down here. What's theta? 250. What's reference? 70. And 350? Theta is 350. And reference? 10. Everybody good? Okay, now, what when I reviewed at the beginning of the class, and we talked about the Cartesian plane, and I told you its new name, coordinate grid, have we mentioned coordinates since then?
Oh God.
No, we haven't. Turn the page over. When we draw a terminal arm, it goes off through an infinite amount of coordinates, yes? So draw that first one. Where would 3, 2 be?
You draw a dot right there,
Put a dot at where 3, 2 would be.
and then we put an angle through it, or line, a ray through it.
Yeah. It would be out here. And there's my line. Everybody cool? Making what? It makes this angle, which has a theta and a reference angle that are the exact same thing. Right? Okay, what about B? Where is it going to be?
It's going to be in the third quadrant.
-5, -1 down here. Gives me a theta and a reference. I should be using 2 different colors. I've been making theta black, haven't I? And the reference angle green. You guys fill that in. While you're filling that in, I will be checking something because I think your book is actually missing a page. It is. I need to print that page for you all. Once we go over this, I'll go and get your assignment that you will be working on. You guys finish that up. I'll go copy it, and that's what you'll be working on. Yeah? Whatever you need to do.
didn't. It's like so confusing. But I can't. I have meetings. Yeah. And here's the funny part, right? Now she accuses me of not handing things into her. If you wind up sending me one, it's been always like out information she was looking for. I hate you know that like
What the heck happened? Oh, right, I did that. Okay. Whoop. There's theta. There's reference. What would you do to solve for these? What would this guy be?
Oh no.
What would this guy be?
180 minus.
No.
180 plus. No.
Theta minus 180. What would this guy be?
360 minus.
360 minus theta. Negative 10, 5. Negative 10, 5. Be up there. There's theta. What would the reference angle be?
It's 180 minus.
180 minus theta. Excellent. 4, 2. Right there. What do you know about theta and the reference angle? It is the reference angle. Negative 4, 2. There's theta. Reference angle is what? 180 minus theta. Negative 4, negative 2. What's the reference angle? Theta goes all the way around. The reference angle goes back.
Theta minus 180.
Theta minus 180. And finally, 4, negative 2. Theta goes all the way around. And the reference angle? 360 minus theta. Everybody good? All right, now the next page in your books is not in your books. I have it right here. That is your work for right now. You should get it done easily peasily by the end of this block. I want to show you the right answers because I did not provide them to you. Okay? Okay. Take one. Pass them around. Nice job. I absolutely can. Keaton DeVries, give me that thing.
I'm so close to that.
Right.
Like in advance. Because I have meetings to attend to. I'll still go. But it's
Right.
I have to talk to people at meetings to keep others from that dog. And then she takes the courtesy to give me that
Right.
having things in, right?
Right.
I mean, if she's not working, who cares?
Right.
Tell you that joke? Yeah.
So that is
Wow. I'm like, what am I paying for?
4 marks. Here you go.
So irresponsible. And like, she said whatever they were just using. And there's no note, nor no nothing. Say when she's coming back. You get last year, right?
Hey, yes or no? No. Why?
It's not at the origin.
Vertex not at 0, 0. B, yes or no? Yes. C, yes or no? No. Why?
Because it's not connected to the initial arm.
Initial arm does not equal the x-axis. D? Yes.
Yeah, it's at the initial.
Without measuring. Find them. 150, where is it? A, B, C, D, E, or F? F, that's little a. Where is 180? C, there's little b. 45, A, little c. 320, D, little d. 215, B, little e we got up to. And F, E, little f. Lovely. Can we go on? What quadrant for 48? 1. For 300? 4. For 185? 3. 75? 1. 220? 3. 160? 2. Nice. Sketch the angle in standard position with each given measurement.
So what if I did a mini one like right beside it?
Red,
Oh, I did a mini one beside
blue,
it.
green, black. Where's 70?
First quadrant.
Right there. Where's 310?
Fourth quadrant.
Right there. Where's 225?
Third quadrant.
And where's 165?
Really close.
Excellent. What is the reference angle for each angle in standard position? Reference only. 170. 10. 345. 15. 72. 72. 215. 35. Holy crap. Somebody must have taught this to you guys really well. Shucks. And down here. Reference angle 72, quadrant 4, so what's the angle? 288. 288 or 298? 288. 360 minus 72. 56, but it's in quadrant 2. 124. 18, but it's in quadrant 3. 198. And 35, but it's in quadrant 4. 325. Hola.
Are you taking this one from us?
Huh? No.
Simon.
No, it's homework. Really? Come on. What math did you bring to this party? Adding.
Yes.
When did you learn that?
You said all math is addition and subtraction and multiplication.
Yes?
Yeah, see. And we did it in class, so it was not taking homework.
Hush up your face. 15 minutes left. What should I do?
We should talk about dinosaurs or something.
Wait, are we having?
Oh, actually, what I should do is mention a couple of things, because as of right now, you guys have departed from the regular tens. Okay? So a couple of things, that implies a couple of things. One, if for some reason there is not a video on a date for you, I forgot to upload it or something, you can no longer watch one of the other classes because it's going to be different for the rest of the year. Okay? So that's one thing to get out of the way. Second thing to get out of the way. We have finished a third of the trig unit. You guys wrote one quiz on SOHCAHTOA stuff. Did you not? Right. We marked it. Have I collected marks? Yes, I believe I have. You will have one more quiz on this part of trig, coordinate geometry, or coordinate grid trig. You will write a quiz on that. Then we will do trigonometry with triangles that have greater than 90 degrees. You will have a quiz on that. Your trig test, you will then do a review on everything but SOHCAHTOA trig. Then you will have a test on everything. This is a big unit. Okay? That's why I'm leading to this. When about 2 days after that second test on Trig, you'll get a cumulative exam. I have explained this many, many times, but I still have people asking about how they can improve their grades. Your grades improve when you write the cumulative exam. Your grades may stay the same when you write the cumulative exam. Your grade will not fall when you write the cumulative exam. Everybody understand? What?
The test is different than the cumulative?
Yes. The cumulative exam is yours to keep for studying purposes. Okay? Don't get it wet.
I got that one. You said purposes at first, and I was like, what about both?
What?
I was gonna say if you got like 100% on it, you just like that part.
Huh? No. Because you still need to practice. Everyone writes the cumulative. And what?
How long is it?
Huge.
Well,
I have no idea. I don't remember.
if you miss it, you still have to do it.
I would recommend that you do it, but it's up to you. It's only if you miss it, then you're only missing a chance to improve your grade. You can take a blank copy from me and take it as notes or practice for later. I don't care. Aight? Damn it, that only took 3 minutes. I should have talked slower. We talked about that. I reffed a rugby game. I bought my daughter some ski boots. I played frisbee golf. I took my dog to